Good day, everyone! Are you ready to have fun with math? I'm your teacher, Jane, and let us make learning more fun. Before we start, here are some friendly reminders to keep in mind. Number 1, stay alert and focus in the video lesson. Number 2, prepare your pen and papers for the solutions of the activities. And number 3, sit back and relax as you enjoy our video lessons for today. At the end of this video lessons, you are expected to: number 1, define and illustrate factorial notation. And number 2, illustrate permutation using tree diagram, systematic listing, and the concept about fundamental counting principle or FCP. And last but not the least, derives the formula in finding the number of permutations of n objects taken r at a time and apply them in problem solving.
Our lesson for today is all about permutation. In this lesson, you are going to illustrate the different arrangement of objects. And also, it answers the question, how does the concept of permutation help in forming conclusion and in making wise decisions? In this lesson, we have here 5, 4, 3, 2, and 1. It's easy to say and multiply 5 times 4 is equal to 20. 20 times 3 is equal to 60. 60 times 2 is equal to 120. And 120 multiplied by 1 will become 120 also. These numbers can be expressed in terms of exclamation point, where in mathematics it is called factorial. I have here an example of factorial number. We have 5 factorial is equal to 120. Hence, by definition in mathematics, factorial is the product of all positive integer less than or equal to a given positive integer and denoted by that integer and exclamation point. I prepare here some example of factorial. So we have 6 factorial and 4 factorial. To be able to find the final answer within this number, so we need to expand 6 factorial. So it will become 6 times 5 times 4 times 3 times 2 times 1 will become 720, as well as 4 factorial. So it can be written as 4 times 3 times 2 times 1. The product will become 24. In factorial, we have special cases. So we have 1 factorial and 0 factorial. Both factorial number will become 1. I have here another example. We have 20 minus 17 factorial. So therefore, in order to find the final answer, all you have to do is to perform the indicated operation, which is minus. So 20 minus 17 will become 3 factorial. And 3 factorial, you need to expand the number. So it will become 3 times 2 times 1 is 6. I have here another example. So we have in terms of division. In terms of fraction, we have 10 over 6 factorial. So all you have to do is to expand the numerator and denominator before you find the final answer. So we have 10 factorial. So therefore, it can be written as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And also in denominator, it will become 6 times 5 times 4 times 3 times 2 times 1. So as you can see, we have here similar numbers. So all you have to do is to cancel out the numbers. So therefore, the remaining numbers will become 10 times 9 times 8 times 7. The product will become 5,040. Next, we have the definition of permutation. It is an arrangement of all or part of a set of objects with proper regard to order, meaning to say, it is order matters. And also, we have the different ways to illustrate permutation of objects. So as you can see, we have 3 methods to use. We have systematic listing method, tree diagram, fundamental counting principle. The advantages of this method is you can see all the possible arrangement of an object But the downside of this method is it consumes time for bigger number of objects. That is the systematic listing method, where you can list all the objects that is given to the problem. While in the tree diagram, it is a simple way of illustrating sequence of events where you can draw or illustrate the given objects. While in the fundamental counting principle, it is a rule used to count the total number of possible outcomes in a situation. I have here different example of permutation that is in a real life situation. So the first picture, we have arranging 5 different books in a shelf. So we can use the permutation to find the numbers of that books. Then also we have possible choices you have in creating your Gcash password. So as I am remember, I have a Gcash number, so I can use permutation on how to solve the possible choices I have in creating my Gcash password. And also we have here possible numbers of LTO plate number can create. So those are the three examples that used in a real life situation that involve permutation. So let's have an example number 1. During fiesta, as one of our traditions, sweet delicacies are always present. Your mother prepares 3 types of this: ubing halaya, buko salad, and sweetened makapuno. If you are supposed to help your mother in preparing the dishes to be served to your visitors, then in how many possible ways can you serve the 3 sweet delicacies? Okay, so the first solutions, we use systematic listening method. So as you can see, we list all the 3 sweet delicacies that you can prepare to your visitors. So we have here ubing halaya, buko salad, and makapuno. That is the first serve you can choose. Then we have the second one, ubing halaya, makapuno, and buko salad. Then the third one, we have buko salad, ubing halaya, makapuno. Then the fourth one, we have buko salad. Second is makapuno and ubing halaya. Then followed by makapuno, ubing halaya, and buko salad. Then the other one is makapuno, buko salad, and ubing halaya. So as you can see, if we can count the numbers of ways we can serve the 3 sweet delicacies into our visitors, we have 1, 2, 3, 4, 5, and 6. That's it. We have 6 ways to arrange the 3 sweet delicacies. Then, we can also solve the problem with the use of this method. So that is called tree diagram, which is you can illustrate or you can give the pictures of that object into your solution. So the first one, we have ubeng halaya, buko salad, and makapuno. So the second way naman natin, we have ubing halaya, makapuno, and buko salad. The third way, we have buko salad, ubing halaya, and makapuno. The fourth one, we have buko salad, makapuno, and ubing halaya. Then the fifth one, we have makapuno, ubing halaya, buko salad. And the other one, we have, the last way, we have makapuno, buko salad, and ubing halaya. That is so creative, isn't it? So we call this method as tree diagram. That is the way that we can use to solve the permutation of the given problem. So also, aside from the systematic listening method, the answer will become 6 also. The same with the systematic listening method. So therefore, our answer is correct. So we have here fundamental counting principle. This is our third method to solve permutation. It states that if there are m ways to do one thing, n ways to do another, and o ways to do another, then there are m times n times o of doing those things. So we can write as m times n times o. So since we have 3 sweet delicacies, so we have ubing halaya, buko salad, and makapuno. So since our first way is we have the choice of three. So one of these we can serve first is, for example, ubing halaya will be the first. So therefore, in these three, we can choose ubing halaya, buko salad, and makapuno. So therefore, we have three ways. Okay? Then the second one, so we have, if we chose, for example, if in the first choices, we chose ubing halaya. Therefore, the remaining sweet delicacy will become two, which are buko salad and makapuno. So therefore, we denoted as two. Then, if in the second choices we chose buko salad, the remaining delicacy will become makapuno and it is denoted as 1. If we write this in figure, it will become 3 times 2 times 1, which is result to 6 possible ways, which is the same with the answer of tree diagram and systematic listing method. So we have a reminder here. In this example, you notice that the factors are decreasing. Another way of writing is 3 times 2 times 1 is 3 factorial. And therefore, 3 factorial is 3 times 2 times 1, which is 6 also. Factorial notation. If n is a positive integer and factorial is the product of all positive integers less than n or equal to n, we also define 0 factorial is equal to 1. So let us proceed to the different examples that can be used and involve a permutation. So I have here, I make some example that involve the other subject topic. So that you can relate to this example. So as you can see, I know that you are familiar with this. This is the chemical bond that involves the elements. So we have the problem here. Find the permutations of 3 chemical bonds that involve the following elements: nitrogen, oxygen, carbon, and hydrogen. So let's have the solution. So through listing method, the possible lists are, so these are the symbols of the elements, the 4 elements. We have nitrogen, oxygen, carbon, and hydrogen. So in nitrogen, so this we need to create a systematic listing. So when we say systematic, it should not be repeated. So we have here nitrogen, oxygen, and carbon. The second one, we have nitrogen, oxygen, hydrogen. So for us to become easy to understand, so I create the symbols of these elements. So we have NCH, NHC, NHO, and NCO. So we have here in the first column we have 6 ways. The other one we have O, which is pertaining to oxygen. We have oxygen, carbon, and hydrogen. Then we have oxygen, hydrogen, and carbon. So we have oxygen, nitrogen, and carbon. Oxygen, carbon, and nitrogen. And we have oxygen, nitrogen, hydrogen, and oxygen, hydrogen, nitrogen, which is composed of 6 also possible ways. So therefore, we have 12. Then the other one, the third column, we have carbon, hydrogen, and oxygen. Then COH, CON, CNO, CHN, CNH. I know that you understand what I'm saying because there have a lesson for these letters. Then the next one, so we have also 6. So we have 12 plus 6, we have 18 ways. Then the other one, we have hydrogen. Get the first column, we have hydrogen, nitrogen, and oxygen. Then the other one, hydrogen, oxygen, nitrogen. HCO, HOC, HCN, HNC. So therefore, if we count those elements, so we have how many? So we have 24 possible ways, okay, or 24 permutation of 3 chemical bonds that involve the 4 elements. So let's now proceed to the fundamental counting principle. So we have n factorial. It pertains to the number of objects. So since we have 4 elements involved, we write as 4 factorial. Then we need to expand as the same with the first activity that we have. So we have 4 times 3 times 2 times 1. What is the answer? Okay, that is 24. So now let's play and learn. Welcome to Mobile Legend. I know that you are familiar with this game. So now let us create some creative way to learn in this video game. Okay, are you ready? Again to our topic for this day. So we have here a problem. In a mobile game, you played 2 heroes, Layla and Vishan, against 5 opponents which are Mia, Aldous, Selena, Fanny, and Lynn. Assuming that 2 heroes can be paired, show the possible paired of 1 versus 1 set of games and how many possible set of 1 versus 1 selected in a game. So therefore, let me introduce to you our players. We have Layla and Gushon. They are partners. Then versus Selena, Aldous, Ling, Fanny, and Mia. So let's have it. So we have letter A. So we have the solution of systematic listening method. So we have possible paired of 1 versus 1 set of games. So in the first set of game, we have Layla versus Mia, Layla versus Aldous, Layla versus Selena, Layla versus Fanny, and Layla versus Ling. Then we have, and to the other one, we have Gushon versus Mia, Gushon versus Aldous, Gushon versus Selena, and Gushon versus Fanny, and Gushon versus Ling. So therefore, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, we have 1 versus 1 set of game. There are 10 pairs of possible game. There are 10 possible sets are paired. Then let's proceed to solutions of by 3 diagrams. So let us see. So we have another way of showing the possible set is through 3 diagram. So I have here the illustration or the pictures of those players. We have Selena, Aldous, Ling, Fanny, and Mia. There are versus Layla. Okay, so we are Layla, and to the other one, we have the same players versus Gushon. So therefore, the same with systematic listing method, we have there are 10 possible sets are paired. So we have another example here using fundamental counting principle. We have finding the value of R, wherein permutation of 9 is Permutation 9 and blank is equal to 15,120. Note that n must be greater than r. Therefore, r must be 8 or less than 8 when n is equal to 9 and r is unknown. The first step you need to do is to have a trial and error method. So we need to consider as r is equal to 2. Then therefore, we have 9 times 8 is equal to 72. Why 2? Because there are 2 number multiplied. So therefore, 9 times 8 is equal to 72. Considering that we have this reminder, r must be 8 or less than 8. Therefore, that is 8. So the next one is r is equal to 3. So therefore, we need to multiply 3 numbers. So we have 9 times 8 times 7 is equal to 504. Then we have r is equal to 4. So therefore, we have 9 times 8 times 7 times 6 is equal to 3,024. Then we have r is equal to 5. Then we have 9 times 8 times 7 times 6 times 5 is equal to 15,120. Yeah. Okay, do we have these reminders? Should be, since r is equal to 5 is 15,120, therefore this is the correct answer. Then permutation 9 and 5 is equal to 15,120. You can recheck your work in these given. So if the number of the total number is the same, therefore your answer is correct. Okay, next we have permutation of 7 and 4 where n is equal to 7 and r is equal to 4. So what will you do? So since we have this theorem, permutation n r is equal to n quantity n minus 1 multiplied by the quantity n minus 2 multiplied by quantity n minus 3. So therefore, we have substitution method. So when n is 7, therefore we need to replace n as 7. Then r as 4, so it equals to 7. So the solution will be like this. Okay, so we need to substitute the numbers for the given formulas. Then we have you need to solve first those number inside the parentheses. So we have 7 minus 1 will become 6. 7 minus 2 will become 5. And 7 minus 3 will become 4. While 7 is just bring down. Okay? So the product of this will become 840. And that is the permutation of 7 and 4. That. It should be simply right. Okay, next. There are 5 sweet delicacies that your mother prepared for fiesta, and these were ubing halaya, buko salad, sweetened makapuno, and leche plan, and buko pandan. If you are supposed to help your mother in preparing the dishes to be served to your visitors, then in how many possible ways can you arrange the 5 delicacies if 3 sweet delicacies are served at a time? Okay, so formula natin when the formula in solving permutation is P is quantity n minus n and r is equal to n factorial all over quantity n minus r factorial, where n is the total number of objects and r is the number of objects selected. So let's use the formula. So we have here the formula. All you have to do is to substitute the given numbers to the formula. N is 5, R is 3. Then n factorial become 5 factorial. All over the denominator will become 5 minus 3 factorial. Then we need to simplify the given. So we have 5 factorial. You need to solve first those number inside the parentheses. So therefore, just copy 5 factorial. Then we have 5 minus 3. It will become 2 factorial. Okay, so we have here 5 factorial is equivalent to 120 all over 2 because 2 factorial is equivalent to 2. Therefore, perform the indicated operation. So we need to divide it by 2. So the final answer will become 60 possible ways. I have here another example involving permutation that can be used in fundamental counting principle. We have the illustrative example, which is finding the value of n. A while ago, we find the value of r. So in this case, the unknown is n. Permutation of n and 5 is equal to 720. So the first step, you need to use the formula. This is the formula permutation. Then the second step is interchange and substitute the given numbers. So we have n factorial all over quantity n minus 5 factorial is equal to 720. 720 is from the given. Then we have here the permutation values that you can use in order to solve the given. So we have here n factorial is equal to 720 multiplied by n minus 5 factorial. The second step, substitute 720 of its permutation number. So we have n factorial is equal to 720. Look for the equivalent of 720. So it will become 6 factorial. Then just copy n minus 5 factorial. We need to cancel out all the factorial notation in order to find the correct answer. So we have here, cancelled out. So we have n is equal to 6 multiplied by n minus 5. The next step is you need to multiply the monomial. So we have 6 times n, we have 6n, and 6 times negative 5, we have negative 30. Then, as you can see, we have similar terms here. We have n and 6n. So all you have to do is to transferred out. So we have n minus 6n is equal to negative 30. Then n minus 6n, so subtracts, it will become negative 5n is equal to negative 30. So we have here a denominator in able to cancel out the given number, which is negative 5. So therefore, negative 5 cancelled out divided by negative 5, it will become n is equal to 6 because negative 30 divided by negative 5, it will become positive 6. Okay, that's all and have a good day.
There you have it! Always remember, in order to learn mathematics is to do mathematics. Once again, this is your teacher Jane